Hi, and this is T. Sharan Kumar from Department of ECE, BVC Engineering College, Vadalari. So today we are discussing about the concept of Cmos transistor circuit design. Coming to the introduction, so first of all, what are the different types of MOS transistor circuits are existing? So generally we have generally three types of MOS transistor circuits. Basically, those are NMOS transistor logic, PMOS transistor logic, and CMOS transistor logic. Earlierly, we have discussed NMOS and PMOS transistor logics. So now we are discussing about CMOS transistor logic. Okay, first of all, and what is meant by NMOS, PMOS, and CMOS transistor logics? In that NMOS transistor logic, we are using only NMOS transistors. That should be either enhancement NMOS transistors or depletion mode NMOS transistors. Coming to the PMOS transistor logic, we are using only PMOS transistors only. That is enhancement PMOS and depletion mode PMOS. Coming to the CMOS transistor logic, we are using the combination of NMOS transistor logic as well as PMOS transistor logic. Simply, the CMOS transistor logic can be defined as the combination of NMOS transistor logic and PMOS transistor logic. Okay, in this CMOS transistor logic, we are using only enhancement mode NMOS and enhancement mode PMOS transistors only. We never be use the depletion mode NMOS and PMOS transistors. And coming to the classification of transistors. So generally, the NMOS transistor consists of two types, that is enhancement mode NMOS transistor and depletion mode NMOS transistor. Similarly, for the PMOS logic also, it has two types, that is enhancement mode PMOS transistor logic and depletion mode PMOS transistor logic. So coming to the CMOS transistor logic, simply it is the combination of both PMOS and NMOS with the enhancement mode NMOS logic. And coming to the CMOS transistor circuit, and simply this is the block diagram, and it consists of both pull up transistor and pull down transistor. So coming to in the case of PMOS transistor logic, the input should be given to only to the pull up transistors only. You never give input to the pull down transistors in the PMOS transistor logic. In the NMOS transistor logic, the input should be given to the pull down transistors only. We never give the inputs to the pull up transistors. Coming to in the case of CMOS transistor logic, the input should be given to the both pull up transistor and pull down transistor. That should be a common input should be given to the both pull up and pull down transistors. And this is VDD, the power supply, and this is the ground, simply VSS. And the output should be always be obtained in between pull up and pull down transistors. And coming to the in pull up transistors, which type of transistors has to use? Similarly, in pull down transistors, which type of transistor has to use? Coming to in the CMOS transistor logic, all the pull up transistors in pull up transistors, we are using only enhancement mode PMOS transistors only, and this is the symbol for enhancement mode PMOS transistor. And coming to in the pull down transistors, we are using only enhancement mode NMOS transistors only. And coming to the if the given Boolean function consists of multiple number of PMOS transistors as NMOS transistors, in that case, how to construct those? Simply, the construction logic should be defined how the both NMOS and PMOS transistors has to connect. Simply, if the given Boolean expression consists of a OR operation, simply that is addition, like A plus B. In that case, simply the NMOS transistors are to be connected in parallel. So parallel in the sense, in the transistor logic, the source should be connected to the drain. And coming to the for the AND logic, the NMOS transistors are connected in series. Series means drain is connected to the source, and parallel means both drain and drain should be connected, and source should be connected. That is the parallel logic. And coming to the PMOS transistor logic, for AND OR operation, simply the transistors are connected in series, and for parallel that is for AND operation. And coming to the PMOS transistor operation, that means how the PMOS transistor is operated for different inputs. Simply see here, this is the transistor, PMOS transistor with three terminals: gate, drain and source. If the gate input signal should be given to 0, then how the transistor should be operated? Simply here the PMOS transistors are operated for the logic 0. That means if you are giving the gate input signal should be 0, the transistor should be on state, simply on switch. Simply it acts as a closure switch. Similarly for gate input signal should be logic 1, then the transistor should be off state. If it is off, means simply it acts as a open switch like this. And similarly for the NMOS transistor operation, this is quite opposite to the PMOS transistor logic. And here if the gate input signal is 0, simply the transistor is off state. If it is off, means simply the transistor should act as a open. That means there is no current flow in between drain to source. Simply it is, the current should be 0. Similarly, if the gate input signal should be 1, the enhancement mode and MOS transistor should be acts as a on switch. If it is on, means simply it acts as a closure switch. Then that means there is a possibility of flow of current from drain to source. Now coming to consider a simple example of CMOS inverter by using CMOS transistor logic. In this case, simply you can consider the CMOS inverter with a Boolean expression y is equal to a bar. Okay, if for the Boolean function, first has to decide how many pull up and pull down transistors are needed. Simply the number of pull up transistors should be is equal to 1. In this case, y is 1. Simply in the Boolean expression, it consists of only one variable, that has to be chosen, 1 pull up transistor. Similarly, the pull down transistor is also be 1, because of the number of inputs should be 1. Okay, here the 1 must be, the pull up transistor should be 1, the 1 must be enhancement mode PMOS transistor, and the pull down transistor is 1, that should be enhancement mode NMOS. And this is the simple logic circuit for the CMOS inverter. And this is the pull up transistor should be enhancement mode PMOS transistor, and the pull down transistor is enhancement mode NMOS transistor. And here the common input should be given to the both the inputs, and this is the output should be obtained in between pull up and pull down transistor. In the MOS transistor logic, in either PMOS transistor or NMOS transistor or CMOS transistor logic, the output should be a complement output. We don't bother about this complement. We can design the circuit for A, it will be automatically generates the output should be a bar. And coming to this is the truth table for the inverter. If you give the input is 0, output should be 1. If you give the input is 1, output should be 0. Now we can discuss how the current will be flows for various input combinations of A. Now we can discuss now. And coming to the circuit operation for the inverter for different input combinations. If the input A is equal to 0, and what will happens in the circuit? Simply see here, if you can consider A equal to 0, here A should be given to both the T1 transistor and T2 transistors, common input. If, as for the previous discussion, the PMOS transistor enhancement mode PMOS transistor should be operated, should be open or close. Simply here for the input is 0, that means the PMOS transistor should be on switch. Simply it acts as a closure switch like this. And coming to the same input should be given to the second transistor T2, it is acts as a open switch because it is a NMOS transistor. If it is closed, means the entire VDD will be pushed towards the output. That means y is equal to VDD, that is equal to logic 1. And parallelly the pull down transistor should be open, that means there is no current flow here. And this is the cases. And coming to the second condition, the second input A is equal to 1. The 1 should be common to both the transistors T1 and T2. And here for the input 1, the PMOS transistor should be off state. If it is off, means it acts as a open switch. If it is open, that means there is no current flow here. And for the pull down transistor, it is an NMOS transistor. For the logic 1 input, it should be acts as a on switch. If it is on switch, means it acts as a closure switch, then the output should be connected to ground. That means the output should be 0. Okay, as for the truth table, we have satisfied the two conditions. If we give input A equal to 0, output is 1. If we can give input is 1, output is 0. Now we can go with one more example for the two input NAND gate. Here this is the Boolean expression for NAND gate, y is equal to AB whole bar. That means here we have two input variables A and B. That means first has to decide how many pull up and pull down transistors are needed, and this is the requirement. The number of pull up transistors should be 2. The 2 must be enhancement mode Cmos transistors. And coming to here, the number of pull down transistors should is also be the same. That should be enhancement mode NMOS transistor. And this is the circuit for two input NAND gate. Here for the pull up logic, and this is the pull down logic. For the pull up logic, we have two input variables A, B, and the operation should be AND operation in between A and B, that is product. That means the PMOS transistor is always be connected in parallel while AND operation is performed. The parallel means here the drain of T1, drain of T2 should be shorted, and source of T1, source of T3 should be shorted. That is about pull up logic. And coming to the pull down logic, the NMOS transistor logic, for AND operation, these two connect in series. Series means the source of the T2 is connected to drain of the T4. This is the circuit design for the two input NAND gate, and this is the truth table for the two input NAND gate. For the different input combinations A and B, the output y is equal to AB whole bar. That should be 0 0 0 1 1 0. For all these three combinations, the output should be 1. For the one condition, that is in both the inputs are 1, the output should be 0. Now we can consider all the four cases. So coming to the first case for the circuit operation, for case 1, that is if both the inputs A and B both are 0, and what will happens in the circuit. And see here, if both the inputs A and B both are 0, here the pull up logic, so both the transistors are on state because both the inputs are 0, because of the PMOS transistors are operated for logic 0. That means both the transistors T1 and T3 should be closure switches. If it is closures, means the entire current should be passed through the transistors and reach to VDD. And because of the both the transistors T2 and T4 both are off state, simply it acts as a open switch. If it is open, means there is no current flow towards from VDD to ground. That means the entire VDD will be flows towards the output. That is y is equal to VDD, that is equal to logic 1. When it is both the inputs are 0 0, output should be 1. That is the first condition is satisfied. And coming to the second condition, case 2, if A equal to 0, B equal to 1. If A equal to 0, the transistors T1 is on state, that acts as a closed switch, and T2, it is NMOS transistor, should be open because both are complement with each other. And similarly for B equal to 1, so T3 should be open because it acts as a off switch. This is PMOS transistor. For NMOS transistor T4, it is open, even though the T4 is closed switch and T2 is open, that is open switch, off state. That means there is no current flow between these two. Then the entire VDD will be flows towards the T1 and pass it to the output y, that is equal to VDD, that is equal to logic 1. That means when the inputs A equal to 0, B equal to 1, the output should be 1. That is also satisfied the second condition. And coming to the third condition, that is case 3, if A equal to 1, B equal to 0. See here, A equal to 1, the transistor T1 is off state, that means acts as a open switch. Similarly for T2, it is acts as a on switch, that is closed switch. For B equal to 0, the T3 should be on state, that should act as a closed switch, and T4 should be open because of the NMOS logic. Even though T2 is closed switch, T4 is open switch, that means there is no current flow here. and again the entire VDD will be forced towards the transistor T3 and pass it to the output VDD. Then again the output should be logic 1. Again we can verify the truth table here. For 1 0 the output should be 1. Now finally the last condition for case for both the inputs are logic 1. And what will happens when both the inputs are 1? Simply see here, A equal to 1 and B equal to 1. Both the transistors T1 and T3 both are off state. That means both are acts as a open switches. If both the transistors are open, means there is no current flow towards the transistors T1 and T3. And similarly for the pull down logic, both the transistors T2 and T4 should be on state. That means acts as a closed switches. That means the output should be connected to ground, that is 0. Simply we can check this, both the inputs are 1, the output should be 0. Now thank you.